Okay. All right. So where we left off before the break was we just from the command line. Where'd my command line go? Yoo-hoo! I lost it apparently. Oh, this is cool. My terminal doesn't want to show up at all now. It's not a good sign. Well, anyway, from your hypothetical command line, you hypothetically would have typed maven jetty run, and hypothetically it would have downloaded a whole lot of stuff. You would have seen it downloading Jetty and all of Jetty's dependencies and so on. And again, this is why I like to use Maven, as I don't want to have to get you to like, okay, download this jar, copy this thing into this place, and run this setup script, and so like, no, forget it. So hopefully you would have seen Jetty doing all that for you, and then at the end of it, you should be able to see something running. Now, we don't have any servlets running in this container, so we couldn't like go to a website and test it out to see that it's working. But just the fact that we can see like, okay, listening on port 8080 or whatever is like that's good enough for us. So I'm gonna try to.
Is that the
here we go.
8080?
Yeah, I think that's. Whoa. My terminal really just freaked out.
Yeah, I guess it is.
Yeah.
It's showing the web enough for it.
If I do maven jetty run, let's try this again. So just actually, if I scroll up, so ignoring all of whatever it might have had to download, the things you'll notice is it first, before it runs anything, it says, oh, I need to compile your code. So this is nice, right? Anytime you go to run your stuff, it's gonna guarantee that you're running the latest version of all your code. It'll copy any resources that it needs. So for example, your web.xml, or any other persistence.xml, any of that kind of stuff that we'll see later on. And then finally it goes and runs. And so you can see some just kind of debug information here. One thing that I mentioned before that I'll just mention really quickly again, it's automatically reloading anytime we update our source. So it's going to be dynamically recompiling on the fly, and so we don't have to keep restarting our server every time we're trying to fix a problem, because we do.
Is that based on like a file being changed? Like
Yeah, it's just based on it's just polling file system every second.
Oh, okay.
So
So it's
does
actually
that
polling. It's not push.
I believe it's polling. Yeah.
does that mean it's deploying the var and restarting it? Or what?
No. So the funny thing is when you just run it like this, just using Jetty run, it's not actually building the full var and deploying it. It's just running the individual class files directly. Yeah, that's a good question. If you wanted to build the var and run it, you would use a different series of commands. So yeah, good question on that. So yeah, finally you ought to see, this started select channels connector business at 8080, started Jetty server, and it also says starting the scanner at an interval of 1 second. So that's where it's polling the file system. Right. If you want to quit this, you just do Control-C. That terminates the Jetty application server. So never before was it so easy to run Java Enterprise applications. Okay. All right. So what we've got so far, and actually for your benefit, I should probably check this in so you can pull the latest stuff, right? So let me do that. Let's do that real quick. We've got an address. We've got contact. Well, I'll give it just a minute. I'll check a little bit more in before I do that. The next thing that we need to do is, we said this is going to be a database-backed application, right? So we need to write some horrible JNDI and JDBC code, right? So first of all, hands up who's used JNDI before? One briefly. All right, so let's go through how to do that. We're going to, so let's make a new, all right, everybody ready? We're going to make a new class. We're going to put it in a separate package, Americana contacts dot repositories. Repositories. So this is what we're going to be building. We'll be building these objects which will do all of our database access. Right. That's what a repository is going to mean. So first thing, let's make an address repository. Okay. So an address repository, well, all right. What's just some database basics, some real just fundamentals here, right? What do we need to do with a database before we can do anything else?
Session.
Hmm?
Session.
Yeah. So that's
Get the name.
that's yeah. So you're both right. I'm asking a bad question. Let me phrase this better.
Create entities.
Yeah. So if you want to be able to store data in a database, you need tables, right? Yeah. So we need some way of doing that, right? We need some. I'm going to have like a public void init method, right? So that's one thing that you guys are going to have to implement, right? All right. So init, we'll probably want to call once at the beginning of our application's lifecycle somehow, right? So that's going to be our init method. And then after that, then what sort of things are we going to want to be able to do? Like what are sort of basic operations that you can do with a database? Insert, yeah. So yeah. So like public void. Let's call it.
Create. You want to do like a CRUD?
Yeah. So yeah. Let's do like CRUD models is sort of what I was thinking. So like create. So create's going to take an address. Oops. Address A, right? Oops. Right. We'll probably since we well we can sort of do this on demand, I guess, but I'm trying to give you a little bit of a feel for what operations we'll need to support here, right? So create, probably delete, right? Public void delete. Let's make better variable names, right? Create, delete.
You want to give the full address for the delete or just the ID?
We could do ID, but probably let's just say it'll just take an address. This will be more consistent with our Hibernate model later on. What I'm trying to do here is set us up for a good transition, hopefully. We'll see how smoothly this goes. Okay, create, delete. We'll probably also want some sort of a find, right? Or find or find all, something like that. So let's have a public address find by ID, I guess. Yeah. So let's just have this return null do, right? Okay. So I mean, let's say that's maybe okay for now, right? All right. So.
Is that the right one?
For this one, it actually doesn't matter. It could be a long object or just a lowercase long. Yeah, this one I think doesn't matter, as long as in our entities, our entities could maybe have null IDs, but when we're finding by ID, we probably want to actually give one, right?
Okay.
Yeah. Okay. So how do we do this then? We need a database connection. So again, hands up who's used JNDI before? Just one? Okay. Do you remember how it works? How you look things up?
Theoretically, it has this unique
URL name sort of a thing, right? To look it up.
Yeah.
Some sort of lookup API as well as that.
Yeah, exactly. Yeah, so you need,
all the details.
and I'm just going to give this to you. I'm going to look it up in my own cheat sheet because I never remember either. Here I've got. If you guys are curious, there's a cheat sheet branch in my GitHub repository. So let me go back and look at my. There we go. Yeah, this is what we want. Oh no, that's terrible. All right, well, we can do it this way. So basically what we want the repository to have is a data source, right? A data source is kind of the most reasonable way for getting connections. So we want to have a private final data source, not an activation data source, right? javax.sql.data source. I'll just call it DS. And we're going to have a constructor that needs to initialize this data source, right? And this is where our JNDI stuff is gonna come in. So we'll have a public address repository like that. We need to initialize this data source, and we need to get it from JNDI. If you guys want to copy along as we're going, that's fine. If not, don't worry. I'm actually going to check this in, just so you can just grab it directly. This since this is a Spring and Hibernate class, this is not a JDBC class, right? So we're going to be doing some of that work, but I don't want you to have to slave over it all too much. Okay, so we need a initial. Context. So you always look up names through contexts, right? Oops. This is our JNDI context. Of course, this complains that it could have a naming exception. So we will just surround that with a try catch. This, by the way, I'll actually spend a little bit of time on this. How many of you guys feel totally comfortable with the idea of resource management in Java? This is kind of a trick question.
Do you do resource management?
Yeah, exactly, right? Right. Java is a garbage collected language, so there's no need to do any resource management, right? Well, it turns out it's not totally true, because some resources you have to worry about, right? Some, for example, like database connections, or file handles, or sockets, or things like that, right? You always want to make sure that you close those things, which, again, you would assume. And let me stand up for this one because it's sort of an important point that I like to talk about. You would assume that the garbage collector would deal with that stuff for you, right? You assume that the garbage collector, as soon as you stop using some sort of an object like a socket or a file or a database handle, whatever, you assume that the garbage collector is going to close those things for us, right? Well, I mean, that's true. It does. But when? When does the garbage collector do those things?
When there are no references for an object.
When there's no more references to that object. Yep, true. Immediately, or?
The scope is lost.
But whenever it actually runs.
Whenever it gets around to it.
It gets around to it, so
Exactly. It's whenever it gets around to it, which is kind of a tricky proposition.
Right.
It doesn't happen immediately when the thing goes out of scope. It's not like in C, right? If something is on the stack, right? If something not heap allocated, right? If something is on the stack in your C application, right? You're writing C code. It goes out of scope, it's gone. Ta-da! No problem, right? which is why when you're doing C++, it's nice to be able to use those stack scoped objects like auto pointer and stuff like that, right? In Java, essentially everything is on the heap, roughly speaking, and so the garbage collector is sort of the big boss, and the garbage collector runs whenever it damn well pleases, right? And it's a generational garbage collector, meaning that some things are more likely to get garbage collected earlier than others, and in fact some things might never get garbage collected. Some things might be in the permanent generation, including possibly our connections, database connections and things like that, which is a bad scene, right? We don't want that situation. So anytime there are exceptions in play, especially anytime there's a possibility of any exceptions, we've got to be doing try finally. Try finally, try finally, try finally. Try finally like crazy all over the place, and it makes our code horribly ugly and messy. This gets a little bit better in Java 7 if any of you are using that, right? But basically the rule is anytime you acquire a resource, then the next thing you have to do immediately is try finally, and in the finally block you close the resource, right? Have you seen this before? Is that like is that new for anybody? Yeah, no? Okay, great. Well, all right. That was just my right. That made me feel better anyway. Fine. So this initial context thing from JNDI, this is a resource, so we need to try, even though we're already in a try-catch block, we need to just do it again. Try finally context dot close. Right? This is some sort of a resource. And then from this context, we can get our data source. Right? That's what we actually wanted. Right? BS is equal to data source context dot lookup. And the name is going to be some sort of a weird name. I'm going to have to go check this out again. Yeah, it's this comp env business. Ah, there we go. What's it complaining about?
Where did you look that up from?
Just from my own cheat sheet, my own notes.
This
Yeah.
is the same name you had it in that web.xml.
Yeah, the way I had put it in my web.xml was just jdbc/trainingdb. The part that JNDI has prepended is this additional namespacing stuff, this Java :comp/env stuff that I just never remember. So I always look it up. I actually don't want to. Do this. I want to throw a new runtime exception with this naming exception.
Does it always use this namespace? I forget.
I believe it does. There's some way that you can tweak it, but
Okay.
I've never cared enough to figure it out. The good news is that especially once we get into Hibernate, all of this is going to go away, right? Right. This part of this is all still to illustrate the pain that we have to go through here. So I'm going to check this in for you. Now that we've got sort of basic setup stuff here, because this was just sort of boilerplate code that I didn't want you to have to write. Let me commit this. So we got address, contact. Oh, you know what I need to do? I'm actually going to move. Sorry, I want to move our address and contact classes. I want to actually create a subpackage called entities to put those in. So I'm going to do refactor move to a new package called contacts.entities. So we've got entities and repositories, right? Our repositories are what's going to be managing the entities.
Is that like a new file that you create?
I made a new package, so it's just a subfolder.
Where was that option? Source?
It was under refactor move.
Okay.
So, I mean, we're moving our kind of context to just context and entities.
Yeah. So we've got two packages now, right? Contacts.entities and contacts.repositories. That's
So you have to create the contacts.entities first, or you just do a move?
if I did move, it says it allows me to create a new package from within there. Again, I'm going to check this in right now. I wanted to put it where.
So you could rename this, right? Or
Oh yeah. You can do anything that you want to.
There's no higher level.
What did I just do? Address, contact. So I just screwed up my Git. Okay. All right. So I've pushed that. I've pushed that up to GitHub now. If you want to get it from there, you can. Otherwise, it's on the screen. But basically, your first assignment is going to be to fill out this init method. So this is going to be raw SQL. So part of this is going to be maybe actually look up a SQL reference. To construct a SQL statement that will create a table, right? It's going to be create table address or addresses or whatever you want to call it. Create table address, and it's going to have what columns?
Whatever we define in the entity.
Yeah, whatever we define in the address entity, right? So that's your assignment for the moment. Okay.
Can you help me to set up this repository
I'm sorry?
from the Git? How do I download from the Git?
Use Git.
I need to set up the repository so I can sync this code.
Uh,
And I can
You are
download.
Git.
oh yeah. So did you clone the repository already?
No, not.
Okay. So do you have the URL for it?
No.
Okay.
Let me come to there.
I'll just put it up on the screen again.
So once you've cloned it, do you say git update? What do you do?
Git pull. Pull. Yes. Yeah. So this is the website. You picked like the worst time to duck out of class. I don't know if you had a meeting or.
So what do you do in init? You just write simple SQL query?
Simple SQL to just create that table.
It won't compile, right?
Hmm?
It won't compile.
Oh well. So where do you do it? Where does this query go?
Yeah, exactly.
Yeah. So
It's like ds dot something, right?
yeah. So we need to. Yeah, so we need to get a connection from the data source, right? And from the connection we need to get a query or a statement, right?
I get it.
Yeah.
It says error untracked working tree file would be overwritten by March.
Oh, right. Yeah, if you actually cloned, that's what'll happen. So you have a few options. You can just stash your changes. So you do stash and then git pull, and then unstash, which will merge the changes.
Stash,
Yeah.
like delete.
Well, what stash does is it stashes them away. It's like, okay, just hold off on these, just put them somewhere else for now, off to the side, and then you can pull.
So you do a git what stash?
Yeah, stash.
You put the URL once again.
Sorry.
Oh, okay.
Yeah, there you are. It's just today's date.
Yeah, that's also causing. Can you actually show me how to the
Sure. Yeah. Let me just make sure I'm paused. Oh, I am not paused. All right. So what do we need to do?
Connection. Pretty quick.
Yeah. So first thing is we need a connection, right? So connection. Java.sql.connection is equal to ds.getConnection, right? Now this, of course, can throw a SQL exception. And the way that I'm going to deal with this is just to say that init throws SQL exception. Let me share a little bit about my feelings with you. Talk about my feelings. I hate checked exceptions. In Java, I hate checked exceptions. SQL exception is what we call a checked exception, right? What does that mean? What is a checked exception in Java? This is for you guys who haven't had that much like formal.
Like null pointer, the exceptions.
No, null pointer is an unchecked exception.
Yeah.
Yeah. All right, so it's the opposite of that. So what does that mean?
You can handle it.
Well, we can handle any kind of exception. The difference is that we're sort of expected to handle this kind of exception. A checked exception, I mean, some exceptions are a little bit more exceptional than others, let's say, right? Some exceptions, like out-of-memory error, for example. Like, I mean, basically anything that we do in Java could potentially throw a null pointer exception or an out-of-memory error or an array index out-of-bounds exception or something stupid like that, right? And if the language forced us to handle those exceptions all the time, our code would be very difficult to read. So the language distinguishes between two different kinds of exceptions. Those like out of memory error, right? Those are like really bad. Like, what are you going to do if you get out of memory? Like nothing. Your program's just gonna die, and somebody will contact support, and that's what's going to happen. But there are some exceptions that are a bit more predictable, like I/O exceptions are typically very, for example, you try to open a file that doesn't exist, or you try to connect to a server that's down, or you try to get a connection to a database that, there's no connections available, or the database is down, for example, right? So those kind of more predictable exceptions, the Java language declares those. It says those are checked exceptions, meaning that we have to explicitly handle them. The compiler forces you to handle them. I think that's stupid. I think that makes our code still pretty crappy. Because in a case where we're trying to deal with a SQL exception here, I mean, maybe we want to deal with it, maybe we don't, but the compiler forces us to do something. Well, anyway, this is me just saying Java isn't necessarily the best language in the world. And the way that I'm dealing with it is I just declare that this init method, and in fact all of our methods in this address repository, are just going to throw SQL exception. By saying that, I say that the SQL exception is somebody else's problem. It's the problem of whoever's calling this method, right? So throw a SQL exception. All right. What's the next thing that we need to do now that we have this connection?
Statement.
No. Most important thing. What was I ranting and raving
Finally.
about? Yes. Yeah. Try finally. Yep. Try finally connection dot close. Right. this is important. It's important no matter whether we're using a connection pool or not. But particularly because we're using a connection pool, it's like, we have a fixed pool of connections and we don't want to exhaust them. Yeah. Okay. All right, yeah, so now that we've done that, now what? Statement, yeah, so statement is equal to connection dot get, or sorry, create statement, right? Create statement. You can import that. Not Java Beans, shoot. Java SQL statement. Okay, what's the next thing we need to do?
Create a query.
No.
Oh, finally.
Try finally, yeah. Yeah. I know. I pester you guys with this, but it's because this is important, right? You only have a certain number of connections to deal with. You only have a certain number of statements to deal with. So finally, statement.close, right? That's another resource. Yeah. And you can see this gets ugly very quickly, right? This is why Java 7 introduces the try with resources block. But I'm not, for this class, I'm not assuming that any of you guys actually have Java 7 necessarily. It's good to have.
How does it look?
Oh, here, let me, I'll comment this out for just a moment. Actually, I can comment. Let's finish this part out together. So let's start here. Let's start in find. So what's, general framework, I'm just going to copy paste this, right? I'll say throws a SQL exception. I'll copy this kind of outline here. And instead of doing the statement.execute, what am I going to do?
Execute query.
Yeah, I'm going to get a result set, right? So result set results is equal to statement.execute query. So what's my SQL going to look like there? Select star from address where ID equals, and then, yeah, ID, right? Yeah, exactly. So then I have this result set, and what do I need to do?
Iterate.
Yeah, so I need to do, I think it's like if I don't have next, then, well, what did I do in my example? Yeah, I just return null. So find returns null, I guess. Return null. Otherwise I need to unmarshal the first row, right? So I do results.next, and that gets me at the first row. So I would do return unmarshal results, right? Refers to the missing type address. What's the issue here? What just happened? Hang on. I think my Eclipse is freaking out. I hate it when it does that. Okay. So that's the basics of what find ought to look like, and let me just make sure. Oh, I forgot something very important. Results is also closable. I keep yelling at you guys about it. I should yell at myself. Try, finally, results.close. Right, a result set is a cursor into an active database connection, so you've got to make sure to close that as well. I knew this looked too short. Right? Okay. So we've done results.next, which gets us at the first row of a result set, which, I mean, hopefully we should only have one row, right? Because our IDs are unique. And then, so I need to implement unmarshal as well, and once we do that, I'll let you guys go to lunch.
If you have two results, but you close it, then it will flush it out.
Yeah. Yeah. Yeah, we don't have to actually iterate over the entire result set. This gives us it gives the database connector the opportunity to be lazy, for example, so that like the result set object doesn't necessarily have to hold everything in memory. Okay, so how does this work then? I need to create a new address, but the address, oh, sorry. Yeah, I have to construct it first, sorry. Address is equal to new address. So address.set ID, well, it's going to be the ID that we wanted, but that should, yeah, that should be in the result set, right? So that'll be results.get.
In long.
It's a long, yeah. And in which column is it? Yeah, column 1. Yep.
You could give names also, right? Instead of one, you could give like a.
Yeah, you can do the column name. Yeah, that's true. Actually, I mean that's sort of that's kind of better design, right? Like to give a specific name, so the ID column, right?
And these would be case sensitive, right?
I'm not sure actually. Yeah, I don't know.
But if you change schema, you would have to come back and change new.
Well, I mean the truth is if you change the schema, whether you have these as names or numbers, yeah, you're kind of screwed anyway.
Let's say you just have to change the name, right?
Yeah.
Not column.
Yes.
You would have to come back.
Yeah. Okay. Address.set street results.get string street, right? Address.set city results.get string city. This is a pain in the butt, right? I mean, this is very boilerplate. We're going to do this only once more. You'll be able to more or less copy and paste this for contacts. It'll be some minor changes. And the cathartic part about all this is when we end up deleting it. Hibernate just ends up generating it all for us. Results.get string state and address.set zip results.get string zip return address. Okay, now of course this thing can throw SQL exceptions as well, so throws SQL exception. Right, somebody else's problem. This is all somebody else's problem. Yeah. All right. Now, of course, we haven't run any of this. We haven't provided any opportunity for any of this code to even be run. It's not called from anywhere, and we're not going to worry about that until after we come back from lunch. It's usually a good idea to test your code as you go, but we're doing cowboy style here, so this is what we've got. Any questions so far on this JDBC madness? Nope. Right. It's straightforward. It's easy enough to understand what we're doing. We get a connection. We get a statement from that connection, which you can also get prepared statements, right? You can issue prepared statements to a database. You execute a query, which gives you a set of results, and then you have to iterate, or in this case, we only have a single result. But you would generally iterate over your results and transform those results into concrete objects, right? Okay. So good enough. Let me check this in, and then we'll break for lunch. Address repository.find. Okay. 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 So the plan for after lunch is going to be we'll implement create and delete. And then what we're going to do is actually try to see this code run. we're going to set up just sort of a dummy little test harness. We are going to use a particular thing in the servlet API called it's a servlet context listener, I believe is what it's called, which gets run when the servlet container starts. So servlet container starts, and from there we'll call init, and we'll try to create some addresses and save them, and we'll actually see the SQL that gets produced, right? Cool. So that's the plan. We're going to do this for address. We'll do it for contact, and then finally we'll get into the crazy business of implementing views, right? We'll introduce something called the model view controller pattern, which is going to be very important when we get into Spring. We're going to do model view controller first with servlets and JSPs, and then we'll do it with Spring MVC. That is, we might not get through all of that today, but we'll certainly get through most of it. Okay? Sound like a plan. So it's 1 o'clock now. Let's come back from lunch at 2, okay? 2 o'clock? Cool.